Hello, everyone. Welcome to the first WasmEdge Community Meeting 2025. It's been a long time. So let's get started. So we have several topics that's maybe interesting to you guys and also to the people who watch it later on YouTube, I think. And so without further ado, let's get started with our first topic, which is the support for vision models. So that's one of those things that's we get asked a lot, because one of the major use cases of WasmEdge and also LlamaEdge has been to run large language models, right? But large language models has since evolved beyond just text. So if you look at ChatGPT, they have supported images like 2 years ago, right? There's open source models has also been catching up in this aspect. So you would see, major providers like Llama, Meta, and Chen Wen from Alibaba has been publishing models that can not only answer questions about text, but also understand images. Maybe soon they would understand video as well. So because of that, the open source runtimes and application frameworks, especially the one in the Rust and C++ space, has been lagging in that regard. So for a very long time, if you want to use the vision capability of those models, you would have to use Python and PyTorch and such, right? But things are changing, so there's a lot of efforts that are going on both within different open source runtimes, in our case, the llama.cpp runtime. And we also have, access to the C++ version of the PyTorch runtime. So because the WasmEdge and LlamaEdge runtime is a cross-platform wrapper on top of those native C++ runtimes. So we were able to provide access to those vision models. And so the first talk in this community meeting is a review and introduction of the work that we have done, especially with the Llama 3.2 VLM Vision Large Language Model. So I'll pass this off to Hydai, who's going to talk about the work we have done in this area and how you can run this on your own computer. So Hydai, please.
Okay, let me share my screen first. Can you guys see my screen now?
Yes, I can.
Okay, let's start again. So basically, we have lots of work to support the vision model in the llama.cpp backend. The reason is that because the llama.cpp backend doesn't support it previously, so we have to, figure out lots of different patches from different repository and then porting them back to the llama.cpp backend and make it work. So it takes us very long time to do this. And basically, this new feature is to support the Llama 3.2 visual model, and you can send the images and the prompts to interact with this model. So I will have a demo later to show you, how to interact with your application with this visual model. And the pull request is already underway, so you can just check our branch on the WasmEdge project, and you can figure out that there is a draft pull request is to add in the anonymous poll, and we are working on how to upstream these changes back to the llama.cpp backend. So if you want to run this, our current solution is we are based the llama.cpp and the 4.4.6 version, and we will rebase to the latest master branch soon. And most of the work are from the Llama patches. We just analyze their patches and try to reproduce the whole pipeline inside the WASI neural network backend. Yeah, and we are use the STD image library for the image processing. So these three are the the technology we used to support this visual model. So if you don't want to try it, because we have not yet upstream yet back to the Llama CPP, so you have to use a special branch here and to build the plugin and use it. And I will say it will take 1 or 2 weeks. We want to merge all of these changes into our main bench, so you can access the preview version after we have a new release. But before that, if you want to try it right now, you have to build it and then run it by yourself. So basically, you have to clone the WasmEdge project, and you have to go to the WasmEdge Neural Network GGML mllama branch. And this command is just like how you build the WasmEdge backend for the WasmEdge project, and then just compile it, and the plugin will under this path. After you get the plugin, you have to build the example. We already have this example on the WasmEdge, WasmCNN examples. You have to go to the mllama example branch and go to this folder, and then just build it. After that, you will get this WASM file. Then you just need to get any image you want, and then just like how you run a WebAssembly application with WasmEdge. But there is 2 things you have to specify here. The one thing is that you have to specify the projection model here. So for all visual model, you will have 2 files. One is the main model. Here is the Llama 3.2 visual model, and you will have the other one is the visual projection model. So you have to pass this model paths to WasmEdge. So we will know how to get these 2 model and load it and execute it. So let me share my another screen to show how to use it. Okay, so basically this is my terminal, and I will show the first one is painting called Mona Lisa, and another one is that the test file is an airplane wings. So the command is that we execute the WasmEdge with the projection model, with the main model, and then execute it. Then you can just ask a question with the prompt, for example, what's in the picture, and then you this JPEG, and you will load the image and process it. It will take, I believe, is a few seconds, because we have to do several image preprocessing and then do the inference. So we have to wait a couple seconds, and you will start to show the output from the inference result. And of course, because I use the Mona Lisa first, so you can see here, it say, the model recognize this woman is the Mona Lisa. And of course, you can ask another question, what's in the photo or something like that, and then give another file like the airplane picture, and then you will try to analyze it. Of course, you can ask more, ask it with a large image or a large prompt. However, if you try to pass a high-res image to the model, it will take more time to process it. So it will depends not only on depends on your hardware, and also depends on your input. Yeah, so if you want to try it, the execution time may be various. So here is all of my demo of it, and we are working on merge the pull request back to our mainstream right now. And once all of the reviewing process are done, we will have a new pre-built assets for everyone. So you will no longer need to build all of this stuff by yourself. We will try to bundle all of them into our Redis patch, and you just need to download it and execute it. Okay, so that's all of my demo for the mllama support, and I will hand back to Michael. Thank you.
All right. Thank you, Hydai. Yeah, that's so I do have two quick questions. Maybe there's if there's additional question, we can answer those at the end. So my first question would be, when you send the image to the model, it takes up the context space, right? I noticed that in your demo, your context space is only like 2,000 tokens. So do you know how much tokens an image would take? Like the one with your airplane?
I don't have the number right now, but if you're interested, I can add a new option to print it.
Oh, so so there is that dependent on the size of the photo? Yeah.
Oh, definitely.
Oh.
Especially if you are use, I believe, Llama 3.2 is fine. You will not grow very significantly. But if you are using the Qianwen VL, and if I remember correctly, it will have a very significant context size usage if you are trying to put a very large photo, and it will in the end it will just consume all of your memory. But I didn't find the same thing in the Llama 3.2 vision, but it will still take lots of space, but not so much. Yeah.
Okay. Interesting. Yeah. So the other question that I have is you need two GGUF files in in the setup. So when we convert those the released, say, the PyTorch files to GGUF, would that automatically come out with for those vision models, would that automatically come out with two files? Or do we need to do anything special to come up with the second GGUF file?
Yeah, I believe the GGUF converter inside the llama.cpp project will do this favor for us, because the main model is how it do the inference for you, but the projection model is how you convert the image to the image embedded. So I would say that's different pipeline, but I believe that there is already a tool to convert it, and you don't need to take care about that for very seriously. Yeah.
So the converting of the image to the to whatever the format that in the prompt is done by in the first couple of seconds that we are waiting for the result to come out. Is that correct? So
Yeah.
okay.
So basically, this visual model I used is not a very large one. So most of the time, actually, is concerned in the first phase, which is just to convert your image to the image embedding. Yeah, it takes lots of time. So that's a reason I will say, if you try to put a high resolution image to it, it will consume more time.
Yeah, it's maybe because some of our say our application with, say, Whisper, we have a FFmpeg component in the API server that does some of the conversion first. So maybe we could consider that, but maybe that's something else in the future. That's we resize the image first, so we don't process, like 4K very large images, right? But that's, so. But the question really is that the other model, the projection.gguf is also running on GPU, right? Can we confirm that? It's not running on.
Yeah. So basically, if you are using our mllama approach, then the answer is yes, you will use GPU. However, if you but this is only for the mllama. The reason is that the opcode used in this model is fully supported by all of the GPU backend. However, if you are trying to use the Qianwen VL, another vision model, the answer is no. The Qianwen VL model can only use the CPU backend. So that's a very different story between these two kinds of the vision models.
Okay.
Yeah, the reason is that that model is trying to use some opcode which is not support in the GPU backend right now. Yeah.
Okay. Yeah, that's well. Thank you so much, and I think this is a much needed feature. And my guess is that we're gonna see it on WasmEdge and LlamaEdge first, and then it would be at the same time it'd be upstream to llama.cpp. Is that correct? Yeah.
Sure, we are working on that.
Okay. Thank you, Hydai. Yeah. So yeah, if there's other questions about that, about the vision model support in LlamaEdge, that's we can talk about that at the end of at the end of this meeting. So so let's move on to the second topic, which is also one of the most asked feature. Whenever I go to conference, people ask me, when are you guys going to support component model? So component model in what as you guys know, in the community, that's it's one of the biggest thing in the next generation of WebAssembly, right? So WasmTime is working on that standard, so they already have some support for that. And but we're gonna be the second large WasM runtime to support that. So but it's also a very complex project. It's the specification is very complex and it's ever changing. So this would be something that we're gonna publish in meaning the support for component model in the next couple months. That's so hopefully that would catch us up to the latest spec. So what I'm gonna pass this to Danny, and who's working on component model support within the WasmEdge community. So Danny, please.
Okay, then the current situation is that previously we first support the string type, that is one of the high level type in the WASM interface types. And now we support the all thing like the list, the tuple, option, result, record, variant, for example. And I also fixed a huge internal problem. So some legacy issue got fixed now. And so what I'm working on now is the plugin for the WASI. Wait a moment, let me share the screen. So the current situation is like this. Okay, can anyone see the screen or the?
No, I haven't seen that yet.
Wait. Okay, maybe I don't give the permission to it. So okay, I stopped it. So anyway, what we are working on is the WASI IO, COI, clocks and file system, and the HTTP. This component module, right? That so we are trying to make this become the C++ plugin in the of WasmEdge and provide them. So I guess that is the all thing what we have now.
Yeah, so I guess the obvious question really is that so what's the timeline? So when are we going to have a demo for WASI HTTP? Which is
for now I am working on 1, 2. Okay, so now I have from my memory is 18 functions has to implement, and now what I'm doing is translating the type in component model that this was an interface type or high level, so I need to compile them. The spec also includes how to translate them to lower level type, the old WASM type. So at this part, we are still working on this, and the situation is I about translate a half in the WASI HTTP, some WASI HTTP example that is a certain example we can we already know it can work, and So we use that example to see what we need to support. And except that internally, we need to have the full resources handler. That is just some runtime representation. And yeah, that I think this is the two major thing. And it would take about next 2 months on it. And for the further like the asynchronous or the that would require more runtime work.
Yeah. So we would we have a release that support component model, but not the the components like WasmEdge TTP before 2 months, to have basic component model support, I mean.
Yes, but the situation is that we actually do have some partially support. But what I expect is that we can work a full functional, so we don't need to do a lot of hack or of course I already have that interface and I can use another encoding, and that's probably easier.
All right, yeah, that's I think that's good progress. I know people have been asking us this for over a year now. That's I remember this time last year people were asking us about that, and I also understand the spec has changed over time. So so things it's a moving target. But hopefully that's so if people are interested in helping out this effort, I think I would encourage you to do so as well. So. Thank you, Danny. Yeah, that's so if you have further questions, again, we can wait until the end. So then we're gonna move to the last topic of the day, which I think is why some of you guys are here, is the next phase of the Linux Foundation mentorship program. So as a context, so every year Linux Foundation has several mentorship opportunities. Basically, they pay for student interns or junior programmers to work on an open source project. It's sort of like Google Summer of Code, right? And so we over time we have numerous projects and produced, I think, quite interesting and very useful results for the WasmEdge and also for the LlamaEdge community. So in this upcoming term, which is the first term in 2025, there's every year they have 3 terms, and each term is 4 months, and so we're gonna also have 4 projects, and we anticipate to fill all of them, because from past experience, each opening would have, I think, 50, 60 applicants, and we would select them based on some pre-tests or some, other criteria that's like resume and, or GitHub contribution and, things like that. So what I'm gonna do is I'm gonna go over the 4 opportunities that we have in this upcoming term, and then we can introduce them, and then you can decide how you want to participate in this, right? So let me share my screen. Okay, so I hope everybody can see that. That's all right. So this is the first one. I chose this one first because that's Danny just gave an introduction of our status of component model. So this one is to implement component models validator. So Danny, would you be able to, tell us a little bit more about that? Because I think, I can talk about that, but I think you are more qualified to, talk about the things and the skills you are looking for and what it is for, and what kind of skill would you need for someone to implement this.
So to implement this, the validator is the a requirement that before you run any code. So like even in some like C language or TypeScript, you probably get type checking, right? So that is sort of validating. It tries to refuse any bad code that cannot follow the shape that the validator requires. So for component model, there is in a design MVP has a description about how it validates the code. And so to contribute this part, I think you would need to first, you can go into that that design MVP, and you just see if you can understood the thing. And in our program, I put the two file there is the include validator validator component dot header and the lib validator validator component C purpose. And this two file is made what you were working on. I already put the infrastructure inside of it. So and this every to do as the command. So what you need to do is uncomment this thing and write the proper code. That's it.
Excellent. Yeah. So, I think if you're interested in compiler and programming language work, I think this would be really an excellent, opportunity to do, for this, right? Because this is, as a student or as a junior developer, you don't get to write things about the compiler or, things like that very often. You learn about that in the textbook, right? But it's but in open source, there's a lot of opportunity, and also because the Wasm component model is really a new low-level programming language. You can think about like, for lack of better comparison, it's like instruction set for CPU, right? That's so you are essentially writing compilers for that. So if you are interested in things like that, I would highly encourage you to explore that. So that's our first. It's also very technically challenging. So that's if you're up to it, I would really encourage you to explore that and then to apply for it, right? So that's the first one. And now let's look at the second one. The second one would be implement a new WasmEdge installer in Rust. So the background of this is that when we started WasmEdge projects, we need an installer because there's multiple components, libraries, and things like that. So initially we have a batch script-based installer. Okay? But then we have a lot of plugins, so we have, if you go to, if you're familiar with the WasmEdge project, we have a lot of plugins for image processing, different AI models, PyTorch, and more recently, the large language model, and also other GenAI models like the Whisper model, the Stable Diffusion model, and, things like that. They all come with their own set of libraries and native applications, but those things are platform dependent. So, so when you install, the installer need to detect, which GPU you have, which CPU you have, which operating system you have, and then install different libraries, right? So things get really, really complex really fast with the batch-based installer. So at one point, we decided to use Python to do the installation because, it's a real programming language. So you can write those logic and those branches easier, right? In fact, the Python installer is also done by a Linux Foundation intern through the same program, a couple of years ago. And at the time, he was an undergraduate student in India, and after that, he came to the U.S. to do his computer science graduate program, and so that was I think a very successful use of the time and effort from Linux Foundation, right? So the Python-based installer worked for a while, and but then there's if you have used Python, there's terrible fragmentation of the community. The Python program that works in, say, Python 3.9 would not work in Python 3.10. Okay, and to make things worse, the Python distribution that comes default with the Mac has various problems. So so that requires the Mac user to install the new version of Python first, and then use our installer. So it's just a lot of headache. So we decided, while we still have the Python-based installer, I think it becomes increasingly difficult to use, like the batch-based installer, right? So what we wanted to do now is to take a page and learn, since we are in our entire community, either C++ or Rust, and the Rust project itself has their bootstrapping, framework, which specifically the Rust Up project itself written in Rust. So Rust allows us to write those installer logic in frankly, in a better programming language, than Python, and and be able to compile it cross-platform. So we just need to distribute the Rust binary for different CPU platforms, and have the Rust program figure out what's what's the operating system, what's the libraries that are already installed, what's GPU you have, and things like that, which environment is running on, and then install the WasmEdge components and WasmEdge itself based on that information. So so I think this is a quite exciting project because because most of the logic is already there. It's in Python and in Bash, and what you need to do is to turn that into Rust, right? And then build a pipeline, build a pipeline, a CI pipeline that automatically generates different Rust binaries for different for different platforms. I would also think this is probably something, if you're interested in AI coding, this is something that you could really try to have, the leading edge AI to see if you just give it the Python program, can turn that into Rust. That's, by the way, I know the answer, it's not that easy, but, that's definitely something that you could also try. So if you are, say, you are fairly new in Rust development, but you are I would say a hacker, right? You have a lot of experience with scripting and messing with operating systems and things like that. I think that would be a great project to build a better understanding of the Rust programming language, and to basically to develop your skill, and then you can move on to even more interesting project after that, right? So yeah, that's this project. We need basically need someone to take our existing work in Bash and Python, and build a unified application with basically the same logic, but rewrite that in Rust, right? So this is a second project I want to talk about. So now we're talking about coding assistant. Now there's a third project, which is also a continuation of one of the successful, LFX mentorship project that we have done in the past, which is to build on mllama to build a Rust coding assistant. Okay, so the background of this is there are lots of coding models out there, from closed source and open source and all that stuff. People are using them in a lot of places. There's, I would say, no less than 100 different IDE plugins or tools that allow people to do AI-based code generations. I use several of them. I use Cursor and that, and things. Of course, GitHub Copilot as well, right? But one of the shortcomings is that they don't have a lot of Rust knowledge, because most of the training materials on the internet are Python and JavaScript, TypeScript. So if you ask it to do something, in all likelihood, it's going to give you Python or JavaScript code. Even if you tell it to give you Rust code, it sometimes will give you code that littered with Python style statements, right? It's not really correct Rust code. So in the past projects, we did what do we call it, Rust knowledge base. So we turn common questions Q&As in Rust, common algorithms in Rust, and common code examples in Rust into a vector database. So when the user comes with a programming language question, we would be able to search the database first, and then come up with a relevant Rust example in the prompt, and then have the model generate code. And that has proved to be quite successful. We have several video demos to show a fairly complex algorithm, and also coding tasks that was able to be generated by the system, meaning there's a large language model and also a vector database with Rust knowledge. That's essentially what we have done, right? But that's leave a missing piece, which is really popular now, which is to scale, to improve the model at inference time, not at the pre-training time. Meaning that's in the inference time, the model could examine its own outputs and then decides whether it needs to improve that or it needs to do more, which is essentially if you look at O1 and OpenAI O1 and DeepSeek R1 and Gemini thinking model, they all do that, right? Basically they ask the model to come up with answers and then self-reflect and examine the answers and then come up with better answers. So it goes on and on. So the more time you spend on inferencing, the better result you're going to get. This technique is particularly useful in code generation like Rust, right? Why? because you don't really need the model to reflect on itself. The Rust compiler can do that for you, right? So when the model spit out or respond with Rust code, the first thing you can do is to run a compiler and see if it compiles, right? And if it does, then there's a pretty decent likelihood that the code generated is largely correct. If it doesn't, then the compiler gives you really detailed error messages, which you can send it back to the model and have the model regenerate and with the first result and the compiler errors, right? So the process could go on until you have the correct result, right? So so this is essentially what this project is for, right? So this is to build a system that is dependent on the large language model, say Chain Encoder or one of the coding compatible models, and then have the improve the Rust knowledge base that we have, especially for this case, right? So how what's the file structure? How do you generate for not common algorithms like bubble search or sort or things like that, but how do you generate code with examples on how to connect to a MySQL database or connect to a MongoDB, things like that. So to expand the scope of that Rust programming knowledge, body of Rust programming knowledge that we already have, and then build the interactive components where the user would be able to use a user interface or use a program to send in their coding task, and it would internally generate the code using the prompts it already have, and then use the Rust compiler to test the example that you have just generated or the code you have just generated. You could also build in unit test and things like that. And then at the end, once go through several iterations to fix all the errors. And once you have all that, return the result back to the user, right? It's like a thinking model, but with the Rust compiler that goes in the middle. So I thought that was it's a project that requires you to have working knowledge of Rust. So you can't be absolute beginners. You have to have know a little bit about Rust, and with a passion about AI and code generation, because that's the majority of the work. I would imagine a lot of the work would be done in Python or in Rust itself, and we're going to build API server, so to speak, right? That's or something that can be plugged into an API server that would allow user to use it the same way they use, say, the existing coding models in OpenAI, for instance. So they would just send in a task and we would give them the results without all those intermediate results, without them have to manage all those intermediate results, right? So this would be, I think, would be more of an application on system project. It's and I also happen to think it's very high impact because coding assistant is one of the major use case of AI. So if we can do this well, that's you could see a lot of adoption. Like our Rust coding assistant has already seen a lot of adoption. We have and I wouldn't say thousands, but hundreds of students using that already. A lot of people are using that to to evaluate their code or generate new code and things like that. So there's lots of things that we can do. So if you're interested, come to this issue and look at what is required. And you can also see a lot of people have already, because this is such an interesting subject, right? A lot of people have already in the comment section gave us their thoughts and even prototype applications that they have built around this area. So so I expect this to be a very exciting internship opportunity. So that's the third one. And then let's see the last one. The last one is is somewhat peculiar, is that we one of the use cases of WasmEdge or for using WasmEdge to run large language model is that, as Hydai mentioned, that we can run multimodal models now, but that's the combined vision and language. But the thing is that we have already been able to run models that combine voice with language, right? So the way to do it is really to use WasmEdge to run a Whisper model, and then you use WasmEdge to run a large language model. So the Whisper model takes the audio input and then turns that into text, and then have the large language model process it. That opens up a lot of interesting, use cases. One of them is translation. So, so you can have a video, and then we extract the audio out of it, and then use a whisper to convert that into text, and then use the large language model to do the translation, and then have the results come back and add, as captions that we can add to the video, right? We have done that for numerous languages, and interestingly, there are several conferences, including the CNCF itself, is using that to translate English language videos into other languages. So we have people who are native speakers of Chinese. So we've done a lot of those, translating English languages videos to Chinese language. But one of the things that we are tasked to do, and we really want to get the community help, is to do that in Japanese, right? So that because right now we can ask the large language model to translate English into Japanese. It's difficult for us to evaluate the results, and without that feedback loop, it's difficult for us to adjust the prompts and and other elements in the system to make the translation better, right? So for this particular task, we need a Japanese native speaker who's also familiar with technical content, especially with CNCF content. Because, when you do the translation, the prompt you give to the LLM are highly project specific. So for CNCF, we're going to teach the model to understand what is Kubernetes, what is CNCF, what is Linux Foundation, things like that. So there's a lot of prompting involved in there. So, to understand the content, the video content that we want to translate, right? So there's so for this particular project, I think it's more relevant to software developers based in Japan, or understand or have worked with the Japanese customers. And but if you are interested in this idea of language translation in general, maybe for your own language, from English or to your own language, or from your own language to English, that you can check out the project that we have called Video Lengua. And there's and it allows you to customize your own prompts and things like that. So just try it out. That's if you're interested in language translation in general. And then again, this is a WasmEdge internship program, because all the tech stack is built on top of WasmEdge, and we are trying to build something that's useful for the CNCF community, so that people can, because they have so many conferences, right? So that people can benefit from all this work that we do. So those are the 4 projects. It ranges from very technical, that's to write elements in the compiler, to beginner friendly, or at least it seems beginner friendly, like writing and installing in Rust, to a system approach, building an application system. It's really application, which is the coding assistant with inference time feedback, the compiler feedback, right? To a very specialized one like this, translation for the Japanese language. So, yeah, that's all I have. We are at the 52 minutes mark already. And so if we have a couple minutes left, so if you have questions, you are welcome to ask. And so I'm going to stop my screen sharing now. You can ask that in the chat. Let me look at the chat. Okay, yeah. So if there's, people, if you are interested in, it's not only that you can apply for those internship opportunities, but you can also participate, because all those are done in the open. It's GitHub issues. You can give feedbacks. You can try to use that. You can try to, give suggestions. We work on all kinds of participation that's in those projects, right? That's so you can engage both with us and also with a mentor, with a mentee. Okay, any questions? Okay. Yeah, that's so the question in the chat is the coding assistant. Can we try updating existing knowledge base with the final correct answers? Yeah, so the project has 2 elements, right? One is to improve the knowledge base, because I think the knowledge base already have a lot, already have correct answers for the questions to ask, right? So currently the knowledge base mostly have, I would say, algorithm questions. So for instance, how do we implement this? How to implement that? And it lacks application examples. So that's examples that we need to, supplement. So for instance, how to connect to MySQL, like I said, right? How to, create HTTP server, things like that. Just provide, examples and short paragraphs. That's the knowledge base aspect of it. The other aspect of it really is that the inference time feedback with the compiler, that is a system that we have to build. So yeah, so I think the answer from the inference time computer is more often in the form of new answer. So for instance, in the knowledge base, we probably already have how to connect to MongoDB. That would be the right answer, right? But the user might ask something else, say for how to connect to the MongoDB with 28 concurrent connections, something like that, right? That's or with a specific crate, not the crate that we have answer for. Then that compile time, we would be able to determine and get the answer. And so then that would be the correct answer for the new questions that are being asked, right? And that can be fed into the knowledge base, absolutely, yes. Yes, so part of this is really generated synthetic data, yeah, that's, I think, yeah, there are lots of things that we can do with that. Yeah. I don't know if there's a pretest for the installer task. You can go look at that. If there's one that we're gonna show that there. But but in general, the installer would be a Rust program, right? So I think the best way to increase your chances in those things is to comment on the GitHub issue and demonstrate you understand what the installer is for, right? Because some people knows Rust, some people knows Python, and different people have different skills. But for this project, we very specifically requires implementing a particular Rust application that is derived from one of our Python or Bash applications, right? So if you can demonstrate that you understand the requirements and you have the basic skill to build that, just you could either contribute, that's would be the ideal way, right? To improve something in our current installer, and that's to demonstrate you really understand it, right? Or you could build something very simple, build a prototype, something that's installs one library, something like that, or do platform detection in Rust, something like that, just to demonstrate that how it works, right? And also one of the other things that I heard a lot, that people talk about that is that if I give, because that's specifically related to the pretest. If I give the pretest answers, how do I know other people wouldn't copy me, right? So that's always a problem. If you give everybody the same question, right? Unless you have a problem, you have way to submit answers confidentially, right? Which we don't want to do for a lot of those projects because it doesn't seem to differentiate, participants that much. But if you make contributions or you do your own thing, it's impossible for other people to copy you, right? That's because they would have to copy the exact problem and the answer, right? That's that'd be really obvious because everyone have different questions, different problems they want to solve, right? So we tend to give a more of a free rein, just so the selection criteria is really to demonstrate that you are more likely to succeed in completing this project, right? By either having, I think the two most important requirements is that first you have demonstrated how to do Rust at the basic level, and the second is really you understand what's the tasks that's involved in the installer, and you can show us that you can do it. All right. So okay, one more question. The various communities which are actively working on. Yeah, so I believe our way of doing the inference time compute is quite cutting edge, so I don't know other people who's doing that. There are lots of effort, like you said, generating artificial data for coding tasks. That's a lot of people do, but they also do that with, I wouldn't say secrecy, but they don't give the data set a lot, So for instance, if you look at the DeepSeek paper, they are the leading open source reasoning models. They talk about how they build the data set, but they don't give you the actual data set, right? So that's so that's also why there's a speculation of they distilled the O1 models, that's where the accusation come from, right? Because they don't publish their data set. For us, we have the way that we approach it. We have a unique advantage, which is the Rust compiler, which does not exist in Python or in JavaScript, because Python or JavaScript code, you can't do it this way. You don't have a compiler that tells you what's wrong, right? That's you have to run it, right? So in our particular case, I think our approach is very unique, and I'm not aware of anyone else who's really doing something like that. And so that's why I have high hopes for that. That's I think it'd be impactful. Yeah. So to interact with us in the community, I think the best way is through GitHub. Because there's a ton of issues. You can also ask questions and comment on documentation, comment on bugs that you find, things that doesn't work, and things are working too slow. So the two major GitHub organization is called WasmEdge and llama-edge, right? So you can go there, and there's a ton of projects that you can potentially try and give us feedback. So I think that'd be the best way to interact. All right. Thank you for participating in that. And I think we are at the end of our community meeting. And I really look forward to seeing you guys if you are interested in the mentorship program or other ways of contributing. And the mentorship program is very competitive, so don't get discouraged if there's some that if you are not selected, because a lot of participants go through 2 rounds. They applied once and they apply second time and they get selected. So we have 3 opportunities like that every year. So this is the first one in 2025. And so there would be more. And also, I think if you are truly interested in this subject, if you can make open source contribution to that, it would also help your career tremendously. That's what people have increasingly looking at is people's open source contributions, because that's very visible and you can see what's going on. All right, thank you so much. And I think that's it for today. See you on GitHub. And if not, I'll see you next month. Thanks.